Good afternoon to all. Myself, Dr. Asik. I am here to give some understanding about the functions of several variables and its application using the calculus method to utilize the notion of function of several variable in your daily life and whatever in the in the sense of engineering purposes. The application of calculus of functions of several variables basically established in several branches of engineering. Basically, you have to understand how the application is being implemented to the calculus of functions of several variables. So you need to know what are the functions of function of several variable are, but you know how the control functions of several variable is basically a real valued function from r cross r to r. That means the input variable is two parameter, and but the output is a single parameter function. So this type of functions can be utilized in the several branches of engineering, basically in the system of control and feedback system, where you can see that the engineering system where several times you need the restriction of input is necessary to control the output of the system. So such type of control and feedback system, you can apply the functions of several variable where you know the input variable may be changed from 2, 3, 4 up to whatever the sense, but the output is a single variable. So you can utilize the functions of several variable to understand the control of the feedback system also. In the sense of numerical analysis, you can also utilize the functions of several variable, because some complex engineering problem are also arise that you cannot calculate the output in analytically. So using the functions of several variable, you can construct the mathematical algorithm to calculate the simulation function of such type of algorithm, and you can apply that to give the solution to the complex engineering problem also. In the sense of mechanical engineering, you know that thermodynamics and heat transfer is the core part of a mechanical engineering system. So you can utilize this core system of mechanical engineering with the help of function of several variables, where you can know that the thermodynamics and heat transfer, that means the notion of pressure, volume, and the temperature is crucial in the mechanical engineering system. So this parameter, temperature, pressure, volume, it can be treated as an input variable of the functions of several variable, and the output is the exact output that you are expecting from the mechanical engineering purposes. In the sense, you also apply the functions of several variable in the civil engineering purpose also. So you know the construction of bridge that is necessary in nowadays. But to construct a bridge, you need to have several type of restriction. Basically, how much load you are going to, and what are the boundary conditions that you are imposing on the bridge to be stable at that same position for a longer years. So to such type of number of loads and the stability of the bridge that you need to know can be also be stabilized with the help of functions of several variable, where you know that the prediction of such type of stability can also be obtained through functions of several variable by using in the notion that the stability of a function using the calculus of the functions of several variable also. The main thing that you can came across to the application in real life problem is the rent or the rate of a plot. You know that a plot that is in the village is different in that is in the town, but you also know that the rate of a plot in a region inside a town or a village is also different from each one to other, and that is basically due to the location of the plot. So suppose you have a plot that consists of a road that you can apply it. Suppose you have a plot here, but the road is basically the axis of the system. So the rate of this plot is also dependent on the position of the plot. Suppose the plot is exactly in this position, so its rate may be different. But if the plot is here, then it is also different, because the connectivity of the roads also depends on the rate of a plot. So suppose that your plot is here, so the rate will be different from this plot, because this plot having the nearer connectivity to the road, but this plot is not nearer to exactly the road, so that plot rate will be also different. So the value or the rate of the plot is also defined, or can be optimized, or can be calculated, or can be approximated using the functions of several variables. So you also know that the rate of a plot or a value of a plot depends on various factors. Mainly, first on the connectivity, and either it is in a town, or it is in a village, or in an industrial area, that is different. So all these parameters, suppose the village or town or an industrial area, or the connectivity to the corresponding side by road, is also important to justify the value of the plot. So using such type of parameters, that is village, town, or the connectivity to road, can also be interpreted in the input variable of functions of several variable, and the output of the function of several variable is a single real number. So that is the required value of this plot. Another way you can also understand this fact, that these functions of several variable can also be used in the sense of market system, stock market system, because the stock market system also depends on various factors. Basically, the stock which you are going to invest, that also depends on several factors. That first, your choice, or its history, background history, or its ownership, or its applicability to the real life livelihood, long livelihood, or in other factors. So how you invest, that type of how you invest your money to such stock, that is also depend on various factors on the basis of your prediction. So that various parameters that are going to think for the prediction, that is also can be treated as the input variable of the functions of several variable, and the output will be the result, either it is yes or no in terms of the prediction of the variable. So functions of several variable in the engineering purpose, that is why it is can be why it is in the syllabus, basically to understand the several real life problem of in the terms of mathematics, can also be treated in the sense of functions of several variable. Another application of the functions of several variable is basically due to the functions of due to the nowadays the IT sector is going to increase, that is machine learning problem is going to increase. So the engineers which are in that branch, that is on the machine learning, that are going to optimize some of these criteria. So the optimization of anything, any business means that you are going to manufacture some product. So that depends on the raw material, that depends on the location of the factory, that depends on the market of the system. So the output of this business is basically to earn profit, to maximize the profit of the business. So functions of several variable can also be treated on such type of conditions to optimize the profit. So the input variables for such type of business can be treated as the rate of the raw material, location of the factory, and the transportation cost to send it to the market. So that these parameters are basically the input of the variable, and the output of the calculus of this variable is the profit. So you can maximize this maximize the profit of your production with the help of functions of several. So for maximization of this such type of production, you need to know how we maximize this production. So for maximization of production means maximize the functions of several variable, the output variable, and for such thing you need to know how we maximize the function. So for maximization of this function, you need to know calculus of these functions also. So here in this video, we are going to understand the how we maximize or how we can optimize the real life problem with the help of functions of several variables. That is the basically core objective to understand the calculus of the functions of several variables to maximize or optimize basically to the real life problem in terms of mathematics. So first you need to know what is functions of variable. So sometimes before I have already told that a functions of several variable is a functions that applied on a pair of real number to give output real numbers. Suppose that is basically the functions f is from real number r cross r to a real number. So what is this functions of several variable? It is a real valued function that applied on a pair of real number. That pair of real number is x and y, and this comes from x is from r and y is also from r, and the output is also a real number. So functions of several variable, basically for two variable cases I am explaining, that it is a real valued function from r cross r to r. You can extend these functions of several variable for 2, 3, 4 and up to rn also. Then that domain of this function will be changes to r cross r2 up to n times. So I am going to explain for only the cases for 2 variable and 3 variable, and you can extend that same notion of terminology for the higher number of variables also. So for the function of 2 variable, it is a function, a real valued function from r cross r to r, and it can be treated in mathematical notion, that is z equal to f of xy. This z is the output real number and f is the functions of 2 variable, and x and y are the parameter. So for understanding of such type of definition, suppose we are going to this example. So z equal to f of xy is basically x square plus y square. So here you take the input variable are x, y, and the output is x square plus y square. So you know squaring of a real number is again a real number, and adding a two real number, that is x square plus y square, is again a real number, that is the required z. So this functions f of xy is equal to x square plus y square is a function of two variable, and its output is also a real number. Similarly, you can check f of xy is equal to sin x and cos y is also two variable functions. And similarly, x square plus xy is also an example of a functions of two variable whose output is a real number. But you can come across the fourth one, that is z equal to x1 square plus 2x1 x3 and x4 x2. Here you check the number of parameters on the right hand side of the equation is 4. So this is an example of a functions of 4 variable. Not is 2 or not is 3. It is an example for functions of 4 variable, but all of these are real numbers, output is a real number. So this fourth one is an example of functions of 4 variable. So I need not be that exactly the necessary the definition to a function of 2 variable. It may be 3, 4 and higher derivative also. So next we want to know how the graphical representation of functions of several variable are exist. So first we need to understand the graphical representation of the functions of two variable. Suppose we are going to write a functions like this, that is f is equal to f of x is equal to y. What does this mean? This means the function is applied on a single variable and it gives a output a single output. So input is x, output is y. That means it is a real valued function from r cross r simply, if we understand. So this is a single valued function, but if we want to plot this graph of this function, it is basically in two-dimensional spaces. For plotting the graph of this function, the graph of f will be basically a pair of element, that is x and y. So you need, for plotting the graphical representation of this function, you need to you have be two variable. That's why the single valued function, if you plot it in a graphical notion, so it will have to be a x in xy plane, but that should be look like this, one of this. Here I am utilize the function y to be a 5x plus 4, and the denominated part is 4x plus 5 type. So this is an example of a single value function, but its output you are checking, if I plot it will be a curve on xy plane. So graphical representation of a single valued function is a curve on xy plane. But if we increase the parameter, that if we increase the input parameter, that is if it is z equal to f of xy, that means the function we have changed the input variable x from x to xy and the output is z. That means it is a function of two variable. So its graphical representation will be basically a surface on three-dimensional space. Since the input variable is 2, so its graph will be in 2 plus 1 dimensional spaces. That's why it is in 3-dimensional space, but its graph will be look like a surface. Here I have utilized a function f of xy is equal to x square plus y square. So you can check, verify that the graph of the function in 3-dimensional space is basically a surface. Similarly, if we increase the input variable from, I have increased from 1 to 2. Now if we increase it to the 3 variable, input variable is 3, that is z equal to w equal to f of x comma. If we increase the parameter of the input variable, suppose we are increasing now the functions from like this, z equal to f of x, y and z. That we have increased the input variable. Then what will happen to its graphical representation? Since the input variable is 3, so its graphical representation will be in 3 plus 1, that is 4-dimensional spaces, and the graph of this function w will be basically a hyperplane. So using like this, from 1 variable, 2 variable, 3 variable, you can increase the input variable and you can plot the graph of the function, and that will be in different notion. For single variable it will be curve, for 2 variable it will be a surface, for 3 variable it will be a hyperplane in 4-dimensional spaces. So these all are about the graphical representation of the function. So now for understanding or the optimizing the various notions of the application of calculus of the functions of several variables, you need to know some of the mathematical notion to understand it. So first notion of the mathematical expression that can be utilized on functions of several variables is basically limit of the functions of 2 variables first. Later we will discuss for the 3, but for the first one you have used the limit of functions of 2 variables. So since it is a 2 variable function, so input variable will be as it will be x and y. But if we understand that what will happen if what is the meaning of limit for such cases? So limit means we have the input variable x and y of the function, but for limit that the input variable will be tends to some fixed value. Suppose we have a fixed point AB in the same plane, and we are approaching to try to find the limit of a function at that point, fixed point, that means at a comma b. So for such cases you need to approach the pair of input variable x comma y to that fixed point a comma b. That will, if we can approach that arbitrary point input variable x comma y to the fixed point a comma b, and if it exists, it gives some value, then you can say that a function have a limit at a comma b, that will be the exact value, that is the output of the functions. So in the mathematical notion, how we write the limit of a function for functions of 2 variables. So for functions of 2 variables, what is the input variable is x, y, but the fixed point is a comma b. So you can approach the input variable x comma y to a comma b to get the limit of the function at the value fixed point a comma b. That is the basically notion of fixed point. But you can also approach this same notion, the pair of input variable to a b, by one method, that is x tends to a or y tends to a. That means at a time you cannot approach. First time you approach through one value, that is x tends to a, or you can approach through first y tends to b, keeping x constant, and another time keeping y constant, tends x approach to a. That is the notion how can approach to the fixed point a comma b. For such type of approaching, two type of approaching are given. You can approach that a fixed point through simultaneously the input variable x comma y tends x at the same time to a point, the fixed point, then it will be a simultaneous limit. But if we approach in a different notion, first keeping x constant and tends y tends to b, then you will get one limit. But in another way, if we put y constant and x tends to a, you get another limit. So these are the repeated limit of the functions. So we'll discuss in the next slides how we can calculate the simultaneous limit as well as the repeated limit also, and what is the relation and difference between them also. So what is simultaneous limit? Simultaneous limit, now I have already told you, the input variable tends to the fixed point a b at a same time, not in the other method. So that is the basic definition of the simultaneous limit. But for mathematical notion, how we calculate the simultaneous limit? That is the obvious question that will be arised. So in mathematical notion, you can analytically calculate the simultaneous limit such that if a number L exists such that for any positive number epsilon and we can find some positive number delta, but the delta that is depending on epsilon, the choice of epsilon that you are getting or choosing, that also affect the value of delta also, such that mod of f of xy minus L should be less than epsilon. But the another condition is that whenever mod of x minus a and mod of y minus b both should be less than delta, then you can say that the functions of two variable f of x, y have a simultaneous limit at the fixed point a comma b, and the limit value is exactly L. That is the analytical notion, mathematical notion to understand how we can calculate the simultaneous limit. Suppose we have an example like this. So we have to prove limit x comma y tending to a comma b, x square plus 2y is equal to 5. So the input variable is x, y, and the out fixed point is the a comma b, that is 1 comma 2, and this is the functions of two variable, that is x square plus 2y, that is exactly equal to 5. We are trying to calculate the functions of several limit of the functions of this function in analytical notion, and for analytical notion you will get this answer look like this. So as per the notions of simultaneous limit, the functions should have conditions like this, that is 0 mod x minus 1 is less than delta, and 0 less than mod y minus 2 is less than delta. So what will happen to this calculation? But we are trying to calculate the simultaneous limit. So you can solve this question. You will get minus delta will be less than x minus 1, and it is positive delta. And another one is minus delta, it is less than y, and it is less y minus 2, sorry, y minus 2, and it is positive delta. Take this minus 1 on either side of the inequality, you will get that is 1 minus delta, and it is less than x, less than 1 plus delta. And for y variable, you will get 2 minus delta less than y, and you will get as 2 plus delta. So we are getting the bounds of the input variable x and input variable y. Now we are going to calculate the limit, simultaneous limit of the functions, that is x square plus y square. So you are getting the infimum value of x is 1 minus delta and infimum value of y is 2 minus delta. So we are first trying to the infimum value. Infimum value of x square plus 2y will be 1 minus delta square plus 2 into 2 minus delta. On solving these values, you will get delta square minus 4 delta plus 5. Since we have calculated the infimum value, that is the lower limit of these functions x square plus 2y, similarly we can find the upper bound, that is supremum value also. So supremum value will be supremum of x square plus 2y will be basically 1 plus delta square plus 2 times 2 plus delta, and in solving you will get delta square plus 4 delta plus 5. So you get the infimum and supremum value. So in the combining these two in terms of inequality, you can write delta square plus 4 delta plus 5 is less than x square plus 2y is always less than delta square plus 4 delta plus 5. It will be basically minus, okay, infimum value, that is the same thing, it is 4 minus delta. Now take minus 5 from both sides of the inequality, you will get delta square minus 4 delta, you will get x square plus 2y minus 5, it will be less than delta square plus 4 delta. But in the definition, we have already seen that this, whenever this condition holds, mod of f of x comma y must be minus L is also less than epsilon. And what is this number? This is some positive number, near about to 0, some positive number. So you can write these conditions again, look like this. It is minus 4 delta, it will be again x square plus 2y minus 5, it is less than 4 delta. Okay, so you can rewrite again this in the notion of mod, that is x square plus 2y minus 5 is less than 4 delta. Now choose epsilon to be delta by 4. And what will happen to this inequality? This definition will reduces to x square plus 2y minus 5 will be less than epsilon. Sorry, epsilon. It will be epsilon. So you can check that the definition we have stated, that is mod of fxy minus L should be less than epsilon whenever this condition holds. So we are supposing this condition holds. That's why we have solved the infimum and supremum of this x square plus 2y, and we are making it inequality to the standard form, that is f of xy, that is x square plus 2y minus L. L is here 5, that is less than epsilon. But this epsilon is also is related to delta, that is whatever we have chosen, that is delta by 4. So it satisfies the inequality of simultaneous limit. So from that you can conclude that the limit x comma y tending to 1 comma 2 x square plus 2y must exactly equal to 5. So how this way you can calculate the limit, simultaneous limit of any function that I have explained. Next thing, the repeated limit. Repeated limit, I have already told you, repeated limit means keeping one parameter to be constant and apply the second one first, and after getting the output of the first one, apply the second one. So that's why repeated limit means it is a function of two variables defined on a region R to approaching to a fixed point, that is AB. So keeping first y constant and tending that let x tends to a. Fixed point is a comma b, so first variable x will tends to a and y tends to b. So we are keeping y constant and let x to be a. Then you will get the limit extending to f of x xy. And what will be this f of xy? This f of xy basically a function of y only, because we have kept y constant but we provided x to a value, fixed value. So this limit will give you functions of y only. Now this will be functions of y, say it be 5y. Next, take, as we have taken y constant, now y tends to be of 5y. If it exists and equal to L, then the repeated limit of the function f of xy at a comma b can be written like this. That is, limit y tending to b, limit x tending to a, f of xy is exactly equal to a. So L is the repeated limit of the functions of variable, but the repeated limit sense, first we approach the functions for x tends to a keeping y constant, and that function will be a function of y only, and later part we approach through that y tends to be of the functions for, that is 5y, that will be a required output L. So this is the repeated output. Another way, if someone approach first that x will be constant and y tends to be, that will be a function of x only. The later part, limit extending to of the functions, that will be against the suppose L. So that L is also a repeated limit of the functions. So there is two ways to approach a repeated limit for functions of two variables. But you think this L and this L is same, that is totally different. They may not be same. Okay. But when it will be same, that we will also discuss. Suppose the simultaneous limit, in the last slide I have got the simultaneous limit of functions of two variables exists and it is equal to L, and the repeated limit that I have just recently explained, these two repeated limit exist, and as well as the simultaneous limit also exists and equal to L, then we can say that the repeated limit is also gives the same value as is the simultaneous limit also. That means the repeated limit are equal, and if the simultaneous limit are exist and equal to L, then that simultaneous limit value will also be equal to the repeated limit value. Suppose this is the required example. F of xy is basically 2x plus 3y divided by x minus 4y, and the point is approaching to the origin 0, 0. So we are trying to calculate to show that the repeated limit are not equal. Okay. So for that, what we have to do? We have to do some calculation of the basic thing. So first we can try to calculate the repeated limit. So since the function is f of xy is 2x plus 3y divided by x minus 4y, and we are trying to calculate the repeated limit of this function at 0, 0. Okay, so for that we have to calculate limit x tending to 0, limit y tending to 0, and this f of xy will be basically limit x tending to 0. Since we are getting the first y tending to 0, that means putting substitute the value of y to be exactly 0, you will get 2, and this is exactly equal to 2. But if we change the order of the limiting, that is, if limit y tending to 0 and limit x tending to 0 of this f of xy, that means you have to approach the limit of the function f of xy first as x tending to 0. So x tending to 0, that means limit y tending will be given as it is, but as x tending to 0, substitute x equal to 0, that means 2x will again 0 and x will be 0. That means you will get y will cancel out, that will gives you 3 by minus 4, that is exactly minus 3y. So you see that is 4 only. Okay. So you see that the repeated limit, there are two repeated limit, but their value is 2 and another one is minus 3 by 4. So you can see that these two variables are not equal. But you can also not equal, that means you cannot talk about the simultaneous limit also. So, and one observation basically on this, I have made it here in the next slide. So if the repeated limits are not equal, then simultaneous limit does not exist. So one conclusion you may draw from here, that if the repeated limit of functions of two variable or any variable is not equal, then the simultaneous limit of this function at the same fixed point does not exist. You can look at this example that I have chosen, 2x plus 3y and x minus 2y. So if we approach directly, that is limit x comma y tending to 0, 0, 2x plus 3y x minus 4y will be basically limit x tending to 0, 2x plus 3mx by x minus 4mx, and that is exactly equal to 2 plus 3m by 1 minus 4m. And why is m here? Because the limit simultaneously xy tends to 0, so there is different path to approach. So we have chosen y is equal to mx for y equal to mx. If we choose this path y equal to mx, so as x tends to 0, y will be again 0, so this limit will always valid. So the limit, simultaneous limits of this given function is basically depends on the value of m. That's why their simultaneous limit will have a different value for different value of m. So the observation of simultaneous limit for the case of repeated limit, you can think that the function will have two different repeated limit. That's why the simultaneous limit of the same function at the same fixed point 0, 0 does not exist, because for the different value of m. But if you choose the example f of xy is exactly equal to x square plus y cube plus log x plus sin 1 by y, and the fixed point is 2, 0, you will get the repeated limit. Both the repeated limit will be equal, and that is exactly equal to log 2. You can calculate, and you can also calculate the simultaneous limit will exist. That means that the repeated limit also have the same value as well as the simultaneous limit for these functions also. So one notion of mathematics, that is limit of the functions of two variables, is completed. Next thing is the continuity of a function. So continuity of a functions of two variable means we have to check the functions at the fixed point and the limit of the fixed point. In the real variable case, what we have done, the left hand limit, right hand limit, and function at that point, if it is equal, we say that the function is continuous at that point. But for the functions of two variable, the limit concept is different. That is, any path in the xy plane can be approached to the fixed point a, b. That's why the continuity of functions of two variables also different from the single one. That is, approaching the fixed point have a different notions. So that's why the limit for functions of two variables, that is f of xy, basically treated like this. That is limit xy tends to ab of f of x. So that is the simultaneous limit if it is exactly equal to the function at that point. If it is they exist and they are equal, then you can say that the functions of several variable f of xy have continuous at the fixed point a, b. But what is the fixed point? Fixed point is at any point in a region. So in the higher notion or extended notion, you can say that the function f of xy is continuous at every point within the region R. Then you can say that the function is continuous in all over the domain R, where the domain basically I am written region R, not the real number. It is a region R. So that's why continuity notion is a broader sense of limit, and that should be utilized in the case for calculus of functions of several variable to discuss the optimality of the functions of several variable for the solution of the real life problem. Suppose this is the function that I have already solved. That is f of xy is equal to x square plus 2y. I have calculated the repeated limit. Simultaneous limit. What is the output of the simultaneous limit? Simultaneous limit is 5. That I have already told you. That is here we have already found the simultaneous limit, that is 5. But here you have to calculate the continuator notion. We have claimed that the function is continuous at 2, b. So we have already calculated this portion, limit xy tends to ab, that is f of xy at the fixed point ab is basically output is 5. For the continuous notion, you have to calculate the function at that point. And what is this function at that point? F of 1, 2. So substituting the value of x equal to 1 and y equal to 2 in the given function, you will get f of ab basically exactly 5. So the simultaneous limit of the functions of two variable is exactly equal to the functions at that fixed point. That's why we say that the function is continuous at the fixed point a1, 2. Analogously, you can also say that all functions do not continuous at its fixed point. Let us suppose this example, limit xy tending to 0, 0, xy by x square plus y square. Its limit it is not continuous. Why? Because its simultaneous limit does not exist. If we want to calculate the left hand portion of this equation, that is the simultaneous limit, if we approaching this origin point through, you have many choices. Suppose your choice is basically y equal to mx. Then what will happen to this? So suppose we are choosing the path y equal to mx. So the limit of this function will basically changes to extending to 0. Since we are going to approach xy to 0, 0, that means as extending to 0, y will again be 0. So reducing the number of variables for this such case, you will get mx square, and the denominator part will be basically x square plus m square x square. And it is exactly again reduces to limit x tending to 0, x square will cancel out from numerator and denominator, it will gives you m by 1 plus m square. So the simultaneous limit is depends on the choice of the part that we have approaching, that is y equal to mx. So for different value of m, you will get the different value of this limit. So for that such case, you cannot say that the limit of the simultaneous limit of the function will exist. So you cannot talk about the continuity of this function xy by x square plus y square at the fixed point 0, 0 will exist, or that it simply you can say that it does not exist. Now we can talk about the partial derivative of the function. So first mathematical notion we have approached for the functions of two variables is limit. Next, the broader sense we have approached the continuity, and now we have to calculate the partial derivative. Since in the single variable case, we are the derivative notion is basically in terms of limit, we can talk about direct total derivative notion. But since we are the number of input variable, that is functions of two variables we are talking about, the input variable is 2, so you cannot talk about the total function. But the total derivative notion will come in the later part. Since because the number of variables are increasing, we are trying to approach the same notion of derivative for the input variable xy for one by one. Suppose we are trying to calculate the derivative for functions of two variables in terms of x only, not for y. So then, how will calculate the derivative? So the derivative of the functions of two variables f of xy in terms with respect to x is basically del f upon del x. The notion is different because the input variable is 2, but we are calculating for with respect to one variable only. That's why this is look like this. And for the limit notion, you can take that limit h tending to 0, f of x plus h comma y is minus of f of xy by h. That is the partial. This is the derivative with respect to x, and similarly you can calculate for y also. And this is and the derivative notion is basically known to us as partial derivative because we are restricting some to be not functional. That is, first one is y, and here in this second one we are keeping x to be a non-functional parameters. That's why the derivative is not total derivative; it is a partial derivative notion. So these are the two things. Now, if we suppose an example to calculate a partial derivative of the function, two variable function f of xy to be x to the power 3 by 2 and e to the power y, then what will happen to this? Suppose we are trying to calculate this partial derivative of this function at the point 1, 2. So our function f of xy is basically x to the power 3 by 2 and e to the power y. And we have to calculate with respect to x that we have mentioned at a point at 1, 2. So first we are calculating the partial derivative with respect to x, and after calculation we will put the input variable or the fixed variable fixed point 1, 2. So first we are trying to calculate f of x y with respect to y. So its limit will be basically limit h tending to 0 f of x plus h f of x plus h comma y minus f of x comma y by h. So the limit will basically changes to x plus h to the power 3 by 2 and e to the power y, and here it is x to the power 3 by 2 and e to the power y by h. Now, if you check, if it tends h to be equal to 0, tending to 0, you check that the numerator is again 0 and denominator is again 0. So that you can does not calculate the limit in such case because it is of indeterminate form. So you are applying the L'Hospital rule, you will get that limit to be in a derivative form. Derivative form means that you can apply L'Hospital rule for the derivative for the numerator as well as the denominator also. Since the denominator is single h, differentiating with respect to h, it gives you a constant 1. So we are not writing this one. We are only trying to calculate the derivative of the numerator portion. So it will be 3 by 2 x plus h, 3 by 2 minus 1 and e to the power y. And similarly here h is not involved, so derivative will be again 0. So what will happen to this? If we put h tending to 0, you will get 3 by 2 x to the power half and e to the power y. So this is the partial derivative with respect to x of the given function f of xy x to the power 3 by 2 at e to the power. But we are trying to calculate the partial derivative with respect to x at the fixed point 1 comma 2. That is x equal to 1 and y equal to 2. So f of x at 1 comma 2 will be basically 3 by 2, 1 to the power 3 by 1 to the power half and e to the power 2. So the final answer will look like 3 by 2 e to the power square, so e square. So this is the required partial derivative of the function f of xy x to the power 3 by 2 e to the power y at 1 comma 2 will be 3 by 2 e square. So this is all about now the derivative notion that we have only asked for the two variable of one variable, that is with respect to x or with respect to y. In the later part of the lecture, we will approach for the more than one. So for the functions of two variable, we are trying to calculate f of y, f of xy, f of yx, and what are the relation between them, how they will exist, or is they are equal, the repeated so the partial derivative with respect to xy or yx are equal or not. If it is equal, why, and if it is not equal, under which restriction that can be equal. We will discuss in the later part of the question. Thank you.